and I'm the technical lead on uSamp's product SurveyBuilder. A little bit of background. Who is uSamp? So what we do is we help companies find out what people think. A more prosaic explanation is we get people to take surveys. And so how do we do that? What we've done is we basically built what is called a panel. And is anyone here familiar with market research? So when I say panel, do people know what I'm talking about? Okay, well, for those that don't, panel is basically a big database of people that we know something about. Primarily, we know various demographic information. We know your gender, we know your age, we know your ethnic background. And so with this database, we can target surveys at the kind of people that they're interested in. So a use case is, let's say you're Coca-Cola, and you want to come out with a new sports drink. And this sports drink, you're going to target at, say, young males that have just graduated college with some disposable income. And so what they typically do is they go and call a company like J.D. Power. Are people familiar with J.D. Power? They do the car surveys and stuff. Anyway, they're actually a very large market research firm. J.D. Power goes and builds surveys, but now they need to get people to take those surveys that match the requirements. So in this case, they might want, say, 10,000 males between, say, the 18 through 35 who have some college education. And they want to know, what do they spend their money on, what movies do they like, what sports do they like to play, et cetera. So they'll write up a survey, and they'll give uSamp a call. And they'll say, hey, uSamp, we need 10,000 males between the ages of 18 and 35 and have gone to college. And they give us all their criteria. We put it into our system. And the people that have come and registered on our site, they will see this survey if they have a match. So we're like eHarmony or Match.com, but instead of matching people, we're matching people in surveys. And so that's kind of how we came about. But a year ago, we started a new product called SurveyBuilder. So we're going to get ourselves into the survey building business. And I don't know if people are familiar with SurveyMonkey or SurveyGizmo. So if you're familiar with those, then SurveyBuilder will look recognizable to you. So what is SurveyBuilder? Well, SurveyBuilder, what we do is we give you instant consumer insights. And what we do is we integrate survey authoring with our panel technology, which is something pretty unique. And the three primary use cases within SurveyBuilder is obviously building a survey. Then you go and you find your target audience, and here there's various criteria that you can pick from. And then once you go live with it, and people take your surveys, you want to come in and you want to do some analytics on it. You want to look at the results. So let me give you a little bit of history. I was tasked by our CTO a year ago to come up with a survey authoring platform that was feature competitive with some of those other platforms that I told you about. But also, too, we have a very innovative and aggressive user experience designer. And so he wanted to sort of take survey authoring to the next level with a lot of UI capabilities. And they wanted it really quick. So they wanted basically a private beta up in 3 months. And they wanted a public launch, which would let you purchase and deliver sample within 6 months. So I had a bit of a challenge here. I had to get something up and going in 3 months, and it had to be competitive. And I had to deal with essentially a really sophisticated UI for building the survey authoring. Ultimately, it's going to have to scale to a high volume of traffic. And I needed to build out a development team, somebody that can get in there and work on it. So I had a lot of decisions to make up front. One of the early decisions was we had purchased a company down in Dallas, and they actually had some surveying technology that actually lets you serve a survey. And it had some scripting capabilities, which would give us sort of advanced survey logic and whatnot. So I was able to leverage that. But that was built over the course of the last 10 years, and it was sort of an old traditional relational database system. But over on the authoring piece, it didn't have an authoring piece. And so over on the authoring piece, I wanted to start from scratch. I wanted to start fresh. And we're a Java shop, and we use Spring. And who here has used Hibernate? Who found that enjoyable? You did, okay, well, there's always one in the crowd. But it's really tough. Yeah, I know. It's really tough when you're basically wanting to build a sophisticated UI to then have to sort of marshal that thing into a relational model. I mean, you're building documents, and documents are nested, and you have arrays with hash tables, which contain other arrays with hash tables and whatnot. And with Hibernate, you're sitting there going, well, is this a bag or a list or whatnot? And I've seen a lot of people just sort of give up and say, forget it, I'm just going to put a text field into this table, and I'm going to serialize it as a string and deserialize it, and admit defeat. So I came at Mongo. The typical use case often is sort of what Tony is mostly concerned with, and that is really high volume of data, high throughput. I came at it as, I don't want relational. I want a document database. I want to store and work in the data that gets sent to the UI that lets me really turn around things quickly. And one thing I really don't want to do is monkey around with schema, and then you've got to change the schema. And I heard somebody describe it as you got to plan a party. You got to call the DBA, and you got to get the sysadmin out there, and everybody's up at 2 a.m. and I hate that. Anyway, I wanted to go document database for that. However, we do have some accounting and financials. You're able to purchase credits. We have to move credits around, and we got to sort of mediate between a number of services, and those things have to stay in place. So I need some transactional support and be able to roll back on failures. So we are using a hybrid approach, which I think typically some people go one way or the other, all relational or all document. We're actually a combination of the two. And so I also wanted to separate out concerns, the building from the serving. And as such, I wanted to be able to implement a publishing model. So you build, you're satisfied with what you see, and we push it out to the live servers. And then to sort of loosely couple these things, I wanted to use message queuing between the two. So what just when we started off, looked fairly briefly, but it didn't take me long to decide. But looking between MongoDB and CouchDB. One thing is, if you're in the Java space and you're using Spring, MongoDB has Spring data support. And that alone, to me, just sort of sells it. But I wasn't thrilled with the notion of REST API as the primary interface between the application and the underlying technology. It just seemed like an unnecessary inefficiency. I don't think your database should act as a REST server, but that's my opinion. Also, too, Mongo does dynamic queries. You can just sort of build these arbitrary queries. CouchDB uses views with sort of a MapReduce type thing. So it just seemed like all in all a better fit. Plus, it was a bigger. We were able to have good corporate support. The 10gen guys. I mean, if you have an opportunity to have them support you, they're really great. They're very helpful. And there's also a large user community. So this was the basic stack. MySQL and MongoDB, that was kind of a no-brainer for our SQL aspect. MongoDB for a document database. Our existing in-house survey engine, but we reskinned it to look better. And we're going to build the authoring platform from scratch using Spring MVC, Spring Data, and FreeMarker as our presentation layer. And then we were using jQuery with templating technology for the front-end framework. And let me just give you a pretty brief demo here of what I'm talking about. So this is our site, SurveyBuilder. And kind of the usual suspects here. We're going to head and log in on this one. And so here's our basic user interface. When you come in, you can see the list of surveys you've built. In this case, this count, I built one survey. I have no responses as of yet because I haven't published this. So this is our authoring platform. And so what you see here is you see a survey with pages, and within pages you have multiple questions. Within questions you have multiple answers, and I can add things like additional skip logic. So I can come in here, I can say, I want to go to terminate page, or by default I want to go to the next page, but let's say I'm going to terminate this person if they choose, I don't plan on taking a vacation, so they're not useful to me because you're not taking it, you're of no concern to me. So you can save that. And so what happened there was we were basically able to very quickly update a Mongo document, and the natural nesting, the natural document orientation of your UI just fits with no question into Mongo database. There's just no transform necessary. So I'm going to go ahead. I'll go ahead and remove this. Oops. So that's all removed. So now what I'm going to do, and this is kind of where we differentiate ourselves. I'm going to go ahead and select an audience that I'm interested in taking the survey. So I'm going to go ahead and say, all right, I only need 10. In this case, I'm going to just make it wide open. You can come in and maybe limit the amount of age and gender that you need. If you need a particular ethnicity, let's say this sports drink is aimed at maybe the Hispanic community, so you're just interested in Hispanics, you can select from there. And then go ahead and we'll save this. We give you some free credits, so you can come in and try it out, not a problem. And he's saying, okay, you're good to go. You're going to need to switch it on. And what's going to happen when I switch it on our panel site, surveyhead.com, people are going to suddenly see a link there. And they'll get paid to take this, okay? And once they see it, they'll start clicking on it. So I'll go ahead and I'll turn it on. It'll probably take about 30 seconds for people to discover it, but you'll start to see the numbers start to increase pretty quick. So in the meantime, see if anybody's found it. We'll come back to this. This sort of ended up being the architecture. Now, at the first initial launch, in the first 3 months, we didn't have this piece in here, and I'll speak to it at some length here. But what we did initially had was survey authoring working off of Mongo. We had the account management and purchasing that was working off of MySQL Hibernate. And then over here in the inner view, we still had this old school engine that we inherited, which worked out great. With ActiveMQ, keeping these two systems informed with what's going on. So for example, if we do some caching over here, and if the survey changes, we need to tell them, hey, you got to flush your cache. So that's handled by the message bus. And so it really worked out pretty well. The Mongo for authoring is a really natural fit. And like I said, you have any arbitrary set of data structures nested in any fashion, it's just not a problem. You just don't spend much time trying to figure out how to map this into something that was never meant to really deal with that data model. So we got our milestone in 3 months. We were able to really implement this stuff very quickly because there wasn't a lot of fussing around. However, at the end of 3 months, we were reporting directly out of MySQL engine. And that was a concern to me because obviously you want your database that's responsible for serving these surveys to be lean and mean and trim as necessary. You don't want it to be this sort of central repository of historical information. So my goal is to get that kind of stuff out of there and into another system for reporting. So as we moved on into the public release, we started thinking about a more robust reporting system. And obviously, doing SQL to SQL was the first thing we thought of. But at this point, I'd sort of caught the Mongo bug. And I began to sit there and say, well, the web is all about documents. We request documents, we serve documents. Why do we have relational? So I wanted to, reports are nothing but a document. So it just seemed to me that Mongo, there were certain natural fits going with Mongo. So we considered Mongo for reporting. The pros of it, the response data and generated reports are natural documents. They have a good, really easy way to horizontal scaling. I'm no sysadmin, but I've been able to, just on my own laptop, within 20 minutes, set up 6 shards. So if a dumb guy like me can do it, that says a lot to Mongo and how they've made administration such a relative pleasure. Obviously, they offer incredibly fast writes. And MapReduce, even though we didn't realize it at the time, actually offers us some advantages in implementing our particular feature set on reporting. And we'll look at that later. However, has anybody even looked at Mongo for doing aggregation or reporting, or gone and done research on the web? All right. The consensus out there is what? What would you say the consensus is?
It's rough.
Yeah, it's rough. Basically, don't do it. So I'm terrible at taking good advice. I said, well, okay, hang on. So let's just talk about the cons of Mongo for reporting. So their MapReduce is single-threaded. It runs as JavaScript. And if you're going to be saving your the output of the MapReduce into a permanent collection, it has to run on the primary. And JavaScript is a single-threaded. It doesn't support concurrency. However, if you're familiar with JavaScript and sort of the event loop kind of approach towards things, they do release the thread every time you call emit in the reduce, as well as every 100 documents scanned. But the single biggest crime is that aggregating in Mongo over large data sets is slow. However, it still seemed like this was a really good approach. There was a lot of potential here. In particular, SurveyBuilder, the kind of usage pattern we have is you launch a survey, new survey, people take surveys, and then it peters out. So you get a big burst, and then it sort of becomes, you aren't getting a lot of changes to your data. Also, too, once the data response is collected, it doesn't change. It's historical. And for our particular usage, we need to be able to define filters, and those filters can be modified. And we also allow you to exclude responses from your report. So that's kind of the problem set we're looking at. So we decided to give it a shot. We're going to say, you know what? Damn the torpedoes, full steam ahead. Let's see if we can get this thing to work. And what we learned in there is because aggregating can be expensive, you only want to do it when you absolutely have to do it. Okay? And one of the nice things that Mongo gives you is incremental aggregation for map reducing. And we took huge advantage of that, but it requires quite a bit. You also want to make sure that these jobs run in the background. You don't want these jobs to run as part of a request. And also, too, Mongo just doesn't, in my opinion, just does not scale vertically. It's not meant to scale vertically. It's meant to scale horizontally. So you got to embrace sharding and look at sharding as the answer. And then also, they're moving from SpiderMonkey to V8, so that's going to help a lot. And then we're really looking hard at native aggregation. So, at the risk of losing my place, let's see how we're doing here. Okay. So not bad. I got basically 9 finishes so far. So let's take a look at what I have going on here. So I'm going to come over to Analyze, and here's the results, what I got so far. So let's see. Oh, yeah, what do you know? 60 people are going to take a vacation in the next 6 months. Slackers. So that's great, though. And which of the following activities have you done in your lifetime? Wow, a lot of people have been traveling outside the U.S. Good for them. Okay, so one of the requirements we had, and this makes us a little different than some of these other providers out there, is we let you define on a per-question basis arbitrary sets of crosstabs. Does anybody know what crosstabs are? When I say crosstabs, does this ring a bell? You're the man. Let me know if you're looking for a job. So crosstabs are basically how many people that said they're leaving within 6 months also answered that they traveled outside. And this is typically what market researchers want to see. So what you can do here is you can come and say, all right, I want to cross-tabulate this with some other questions, okay? And we'll take it, we'll just do an entire crosstab across all of the following question. But actually, I'm primarily interested in travel outside the US. I'm going to unselect all of these. And by the way, if there's a bug here, it's all Galen's fault. So. But Galen's brilliant, so there's never a bug. Okay, so what am I seeing here? I'm seeing the breakdown of people. There are 4 people that are going to leave within the next 6 months that also have traveled outside of the US. So you can see a breakdown this way. And so what am I doing here? You come back to this page, and we preserve that information. We know that that's what you requested, so we keep it. Also, too, you say, hey, chart, you're in my way. I don't care about you. I just want the data, please. So you can remove that, all right? Now, we preserve that. So if you come back to this page, we remembered that you didn't want to do the charts. So this all matters. And I actually shudder at trying to implement this in a typical having everything into a relational database. And Mongo made this really possible. I think we did the whole thing in about 3 or 4 weeks or something, at least this aspect of it. Okay, so yay for Mongo. Okay, getting back. So let me talk about incremental MapReduce. How many people have looked into Mongo MapReduce just in general? Have people read or considered what was going on with incremental MapReduce?
Read but not tried it.
Sorry?
Read but not tried it.
Okay. It's actually not that well promoted, but it's really the only way we could deliver this. And what it means is, in our case, you get in a bunch of responses, you aggregate. You get in a bunch of more responses. All you really need to do is aggregate the delta and add that to the previous. You don't need to start from the beginning. I've already done it once. So incremental lets you do that. It lets you just say, I want to aggregate over the incremental and then reduce it with the existing data set. Okay? And sort of following on with Tony, in order to make this work, you've got to keep things small. You can only, Mongo's not particularly fast over large data sets. So you need to keep your data sets as small as possible. Easy to use, a little difficult to manage. And so here's an example. So when you say MapReduce, you just specify merge, and that tells it to do an incremental MapReduce. So how do we do this? All right. Here's kind of an overview. So what the crux of the solution is finite state machines. Who here knows what I'm talking about when I say finite state machines? Okay. You raise your hand every time, so I definitely want to talk to you afterwards. So finite state machines is basically sort of a comp sci concept where you keep track of events, and when events occur, that might have an impact on the state of an object. And as a side effect, an action might get invoked. So the 2 big things we care about here is we get in a survey response, or someone comes to view a report. And what we do is we have this document here in Mongo that that keeps track of the state of the report data. And in the case of a survey response, we mark this report state saying, hey, you're dirty, but you aren't invalidated. So when you come to view, we look at this state and say, you're dirty, but you haven't been invalidated, so I'm going to run an incremental MapReduce job. And what he'll do is he'll suck out the response data, he'll build the resulting report data, and that includes crosstabs. And then what we do is we then take this data, along with this report definition, which says he wants these crosstabs, he doesn't want display options, and all the little things he selects, and along with the survey document itself, and we merge it into a single view, which is the report. Okay, and so one thing you have to make sure you do if you're going to do incremental is you need to keep track of my data set. Where was the last time? So when I ran my map job, I got up to a certain data point. So what I need to now do is run my map job from that data point to now the last data point. So this guy keeps track of that for us. Okay. The filter, I haven't really spoken about, but you can basically define a bunch of queries. You can say, okay, run this job, but I only want to see it for people who answered a certain question. And this, if you haven't seen it before, is what a state machine looks like. And as you can see here, we keep track of the kind of dirty. If there's something that's invalidated the data, you change your filter or you excluded a response, that invalidates the previously built aggregated data. So we mark it as full. Otherwise, this is incremental. And so I won't go into detail, but if you're going to go this route, you're going to need something like this. Okay. However, when we first did this, we still saw that it was pretty slow. And we sort of were holding our hope out for native aggregation. We knew this was in the pipeline. We actually went so far as to write a whole implementation of the reporting using native aggregation. We could see performance improvements. However, once we got involved in the crosstab, we realized that wouldn't meet our needs. In effect, has anybody even looked at native aggregation or aware of what it is? It's basically a pipeline approach. You basically take a set of documents and you send it through a number of stages within the pipe. And these stages can transform the data, it can aggregate the data, and we can pipe it on. The one thing about native aggregation, though, is it might be what you call a single path. I don't know if that would be a technical term. But in effect, crosstab, we have to sort of compare one set of documents against another set of documents, and then we need to kind of come back and compare it against another and compare it against another. And unfortunately, that kind of functionality doesn't really exist in native aggregation. However, there are still various queries we're running against our SQL that we're looking to migrate to Mongo. And so we're looking to see if this is a potential for native aggregation. And one of the queries we're looking at is what we call survey finishes by day. And I'll sort of come back here. And hopefully, oh, I'm over there, aren't I? Okay, let's go over here. Okay. So if you look at this graph here, this is your traditional group by. In this case, we group by day. Okay. This is the sweet spot for native aggregation, if you will. This is what they're good for. So let's take a look. Let's see how we're doing with this. We're still running on native SQL, but I'm going to run some comparisons. I actually ran the equivalent functionality on my local MacBook. Don't set this in stone. This is just some test runs I've run, but I'm going to show you some comparison numbers that at least I came up with. This is basically the SQL query we're running right now. A little slightly different, but I wanted to get apples to apples. So it took me a little bit to figure out, but essentially we're grouping by the day, which is pretty straightforward in SQL. You basically say group by day. A little bit different in the case of Mongo. So like I mentioned, native aggregation is a pipeline. And so you denote each stage of the pipe as a JSON object. And so the first one here is basically matching. I say, hey, find me this survey ID with this, and this status implies it's a finish, and basically anything since the 1st of March. Okay, and then I group by, and I basically say the day of the year. Pull out the day of the year and make that the group. And then what he'll do is just simply count a sum of 1. He's just basically adding for each match there. So also, too, another potential here that we're looking at replacing is just simple counts. Okay, so I just wanted to count the number of finished surveys from March 1st. And these are the equivalent queries here. I won't go into it. So I ran it on just a single Mongo instance versus a MySQL instance. And you can see we're talking an order of magnitude. It's 10 times slower than perhaps MySQL on that same query. like I've mentioned, though, this isn't a particularly large data set. It's basically 12,000 survey responses that we're looking through. But you can shard. And shard, and I kind of hopped from 1 to 5. And the reason for that is I kind of added in the second one, added in the third one, and I realized that, oops, this thing wasn't sharding evenly. So rather than try to start all over again, I basically copied it over to another collection. At that point, I'd gotten to 5 shards. And so I just distributed on 5. So I kind of jumped from 1 to 5. And you can see there's definitely a reduction by sending native aggregation into parallel. But even at 5 or 6 servers, the 6th one you start getting some diminishing returns there. We're still considerably slower than MySQL. However, what's interesting is the counts. If you just do a count, now the trick here is I have an index that matches the count. So it's able, I'm no Mongo expert, I'm sort of looking at Tony, but if you do a count and it's able to basically work off of the index, he'll use the index. And that's also the way sort of MySQL operates. And as such, you can see that you're basically getting equivalent times here. What's really interesting is you start sharding that, and it really drives down that count. So what am I saying here? Native aggregation is newly introduced. It's not as performant as MySQL. If you can use counts, in particular if you can count off an index as an alternative, you can really get high performance numbers. So what am I taking away from this? It's still not comparable to SQL, but we're getting there. It's definitely a lot faster than just plain Jane MapReduce in Mongo. One of the issues, and I want to iterate that it's still not released yet, and they're still working on it, but we have seen high memory utilization around native aggregation. If you're using native aggregation, obviously you've got to go sharding. And one potential you can actually do, and I've tested this out, is you can limit. Basically, the number of documents it has to aggregate over, it's a linear function, and it just slows down accordingly. You can limit it. You can say, even though I got hundreds of thousands of documents, I'm going to limit it to just 1,000 to aggregate. And you can then, from your application, send that off in parallel. And that can be broken further down into shards. And then you can do sort of, if you will, the final reduce in your app layer. So there's still potential here to get close to native MySQL performance. Other ways of aggregating. I have not done this myself, but if you have tons and tons, if you're talking now 100 million documents you need to aggregate over, even with these kind of using incremental and being as selected as you can and as sharding as far as you go, there's a limit to what you can achieve with Mongo MapReduce. You can hook in Hadoop. And so you can maybe offload it to a more powerful engine. I myself haven't used it. I would love if somebody had experience having used this. Has anybody looked into Hadoop with Mongo? Has anybody tried that? How did it go?
The way that we split up our data kind of made it practical.
Okay.
There's some use cases pretty well, though.
Okay. There's a presentation out on Tengen's website that you can take a look at. V8's coming out. And this is kind of a big deal, at least to me, because one of the things they're working on, and I don't think they have a commitment yet to the release, but we'll now have multi-threaded JavaScript. So that's a big impact, not just for MapReduce, but for other functions running inside of Mongo. So having now worked on this for a while, my conclusion is that, contrary to popular belief, Mongo can be used as a reporting system. But sort of what I say, the tips and the tricks, they're just not going to get you there. This isn't about shortening your field names. That would help. But it's not just it's not just, oh, it's a matter of tweaking this and woo, it all works. No, you're going to have to architect your system to take advantage, to play to Mongo's strength. And you've got to put in there incremental MapReduce and sharding if at all possible. I think native aggregation looks promising. We're going to use it but it's limited. So we're not going to use it across the board for everything. And like I said, if you can do the counts and you can work on an index, do it. And then we talked about Hadoop and V8, and that's also, it's promising. From where I'm at, I'm really glad we did this because trying to implement the feature set we did, and if you look at some of our competitors, they have a real hard time, I think, quickly sort of allowing you to construct reports. And we're going further with this. We're going to have a full reporting that just lets you drag and drop and componentize your reports and build it in. And I'm going to go a little bit out on a limb. So if you think about crosstabs and the way we built this, the number of crosstabs are going to be n times n minus 1. So you've got possibly an order of magnitude of like n squared number of crosstabs. And in SQL, what you would probably do is each crosstab would represent a SQL query that would then be union. So you're talking about a large number of queries that would get built. MapReduce lets us do the map in one pass, even with n times n minus 1 crosstabs. And so the scale of growth for us, it helps keep that under control. And so it's a nice architecture for what we're trying to achieve. So that's really it for me. And I want to thank you all for having me. I'll take some questions a little bit later, but actually my coworker Galen is going to give a really short presentation of how we used Mongo for a particular point of interest study that we did for a major consumer company, and how we were able to collect lat and longs with our mobile surveys and correspond it with points of interest. And he did it in about 4 hours, and we hadn't done it before. So I think that really speaks to what Mongo's all about. Besides just high volume traffic, it's an incredible productivity tool. So I'm going to hand it off to Galen here.
Yeah, a story about how easy it was to get off the ground and actually implement something. So I'm just going to do a quick talk about how we leveraged the geospatial stuff in Mongo. And once again, I'm Galen Hollins, and I work at the same company, uSamp. I'm going to just skip over this since Andy did a great job already of introducing what uSamp and SurveyBuilder is all about. Basically, like Andy said, we have SurveyBuilder, which is just a product which lets us author surveys and push those out to users who can take it. We also have something called iPoll, which is a mobile app. And so people on their iPhone, their Android can go take this. And the nice thing about mobile apps is a lot of them let you automatically collect latitude and longitude data. So what the CTO came to me in the morning one day said, we need to associate these survey responses to a certain target location, target meaning the target store. So what we ended up trying to use was Mongo Geospatial. And so across the continental US, there's about 1648 locations of targets. And I basically went and collected this data from a publicly available repository called GeoCommons, transformed it into a CSV file, converted this into a bunch of Mongo insert statements, and populated a collection. So that was a pretty simple process, and that only took maybe an hour. And this is just some example inserts, just grabbing 2 random stores, and you can see that each store has its own latitude and longitude and a bunch of other information about the store, state, address, zip, etc. So we ended up building a huge, not huge, but 1,600 records into a collection. And the nice thing also about having this in a collection is we could sanity check the data. We could run an aggregation query against that data, and this would essentially give us the min and max, and we could take this and then visually just double check against a map of the US whether this data looks like it's in the right place. So this was a really quick and easy way to essentially validate the data. So you can see, the max is 48. So I just kind of drew lines at, here's about 48. You know, this essentially boxed the continental US. So that was kind of cool that we could just get that data out really quickly using aggregation. So that was great. And we also could then take this min-max data and essentially create an index. And some of the Mongo guys could probably answer questions about whether this would help in performance, but at a very minimum, setting a min and max constraint on the index would validate input data coming into the system. So that's also nice. So if you had, you know, Mexico City target store, it would reject it. And you would say, wait, you know, right away you would know that that's not valid. I don't know how well you can read this, but this is essentially just a sample of Java code that's going to iterate over all the responses, get out the lat long. Excuse me. It's just going to run a command. In this case, we're using geonear. And that gives us the nearest target store. We're ordering by the nearest one. So in this case, all we were interested in was getting excuse me, the nearest one. Once we get the store, we could just print out information about it, and we're all set. So just some sample results. Here's just a smattering of the results we got. You can see different OSs coming in, the lat longs, and the locations. So one thing you just have to realize when you do this sort of thing is that the Earth isn't a 2D plane, and these queries are giving you results in degrees. So if you were doing a query up here, the distance, the physical distance on a 2D plane between longitude lines is less than closer to the equator. But in our case, it didn't matter since we're just ordering by the nearest ones anyways, and just getting the nearest one, so it was okay. So that was it. Short and sweet. We got results, populated our tables, and that was it.
Anybody have questions for either Galen or I?
You're building a survey. When you design kind of your schema, you know, whether or not you do a collection per survey or a document per question, how did that help or hurt in your reporting choices? And would you change that at all?
So the question is, how did we go about deciding the general scheme of the survey and whether or not it hurt the reporting? So the fact that I'm the project lead means I get to make certain dictates. And what I said was the UI dictates the data model. What I wanted was the document in Mongo was there to support the UI. And I wanted minimal transforms between that. So the UI requirements sort of dictated the structure of that survey document. And then I referred to the publishing. I really didn't go in there, but the general principle, the general rule was survey, the survey document stored in Mongo supports the UI, and it's up to the publishing process and it uses an adapter pattern to adapt that data model from the data model that existed over in the survey engine. So any discrepancies between that two data models was handled by the publishing. Okay. So in the reports itself, I won't bring it back up, but I mentioned we got three basic documents. We got report definition, which is in fact a meta document. It sort of dictates the person wants to see a graph. He doesn't want to see a graph. He wants to see this crosstab, etc. Then there's the report data itself. So for each component that we aggregated, it has its own document. And then there's the survey, and it all gets merged together. And it actually is a natural fit. I mean, if you look at the structure of the reports, it's very similar to the structure of the authoring. It's not broken down by pages, but it's broken down by a sequence of questions that match the sequence of questions in the what we call the builder, the authoring tool. So it's actually a very close match. And there's really actually not a big difference between the data model that supports the building UI from the engine. There's some slight, but it's not too far off. And likewise for the reports. They kind of closely match, so it really wasn't a problem. Any other questions?
Can you describe a little bit about how did you couple between the MongoDB and the SQL database?
Right. So we modeled the actually user accounts in MySQL. And there we wanted to hold on some financial information about the user. And if you look, there's, I'm not going to fuss with the laptop, but in that promote page, when I purchased that target audience, what we do is we set aside a number of credits. And for each target audience, we sort of account per how much credit's being consumed by a given target audience, because you can have multiples of those. And so that's all related to the user. So because that aspect is in MySQL, we also needed a record that represented, if you will, the survey that's been published to the engine. And that's referred to as the project record. So there's actually a row in MySQL called project, and that has all the keys. So it has the key to the survey object in Mongo. It has the key to the primary key of the corresponding survey over in the engine. And then we also have preview capability, and it has the key over on the preview as well. So the master record, if you will, is in MySQL, and it has basically the object ID that's stored in a particular column for a given project. Did that answer your question?
So then if I'm a user, I log in and I'm creating a survey. What's the process? Like,
right.
The key is created first in the SQL, and then you fire up something that creates the data in Mongo?
So the first thing that happens is we get an object ID. So we pull out an object ID. And then we preserve the record in SQL, but inside of a transaction. Okay? So we haven't committed yet. We then go into Mongo and we create that survey document. And that's another thing about Mongo. If you get involved in it, just remember that the default setting for Mongo is basically a fire and forget on writes. So if you write something in a document, we basically create this prototypical survey document. We write it to Mongo, and it fails, you're not going to know about it. And so the good news is you can basically say, you can define your level of consistency. In our case, we say, it's not a billion people going to be creating surveys at once, so we don't care so much about speed. What we care about is consistency. So we say, we're going to hang out, don't return to me until this thing is written to disk. So we know that it's successful. So then at that point, we commit the record to MySQL. If there's a failure, we can basically roll back the transaction, and we don't record that. So there again, there's a lot to be said for SQL. It's got transaction support. So there's times when you need that.
And then your UI reads this
Yes.
from the SQL or from the...
No. Once you're in the editing mode, and once we got that prototype object, the document into Mongo, now the UI is working strictly with Mongo. And then when you click on the promote, there's a publishing process, and that does interact with MySQL. So it's a hybrid. It's a hybrid approach, and I think in my opinion, we're pretty good about picking the right tool for the right problem. Over there.
So I'll follow up on that. So you're using like a GUID for the key to do this linkage between Mongo and MySQL?
Yeah, we're using sort of the standard Mongo ID, object ID, which produces a GUID. And so you can go and actually pre-allocate that GUID before you even write before you write that document.
I thought you said the MySQL owned the key first.
That's right. So if you will, the sequence is we write the record to Mongo, to MySQL, but no commit. Then we create the document using that. We pass in that object ID that we just created and say, that's your ID. You aren't going to dynamically create it. We're going to tell you what it is. And if that succeeds, then we commit the transaction, and everything's consistent.
I have one other thing that's sort of unrelated, but I was curious. You said you were using ActiveMQ, and I'm like evaluating queues right now, and I was curious, did you look at Rabbit, or like why did you use Active?
So one of the things that's interesting, when we picked Mongo, I started getting a lot of emails about oh, Mongo sucks, blah, 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 blah. Likewise, when I picked ActiveMQ, I got also a sequence of those. So let me just sort of, I know this is off of your topic. I'll just say this for those, who here is running Mongo in production right now? Really? Okay, so who's sorry, do you mean that?
Well, I've built stuff that is in production.
Okay, who's evaluating? Who's considering this? Okay. So I think what's worth about Mongo is fully understanding its limitations before you commit. One of the things I hope you take away from this aggregation is you can't treat the aggregation like you would MySQL. Okay, it just doesn't act that way. You've got to embrace sharding. You've got to embrace things like incremental MapReduce, and you've got to manage that process. So knowing its limitations means you have not such a bad experience. ActiveMQ, likewise. ActiveMQ has sort of a mixed reputation out there. It's probably the most used message queuing, but there's a lot of people who have issues with it. I've used it in the past, and I myself have not had particular problems with it. The one thing that ActiveMQ gives you that you can't get with RabbitMQ is embedded brokers. Okay, and in our one of the things was I had to build out a development team, and I need each developer to quickly be able to build and deploy and run this system on their local laptop. Okay, I didn't want to have to I didn't have to say, well, yeah, you have to start this up, and then over here start another RabbitMQ Erlang server, and that's a whole different technology stack. You can basically embed your broker into your Java app, and so in a development environment, you have a much more compact environment. And so that, to me, was sort of the critical thing. The other thing is we use Camel, and so Camel just is a natural fit for ActiveMQ. So RabbitMQ has a very good reputation. It's by the guy, Spring Source, people own it. So I don't have anything bad to say about it. It's just...
you got to go with the wave, not against the wave. So you use a tool the way that it's good. So.
Right. And by the way, so the two primary suspects in our system is always Mongo, and it's always ActiveMQ. It's like, oh, there's a problem. Oh, finally, Mongo's being sucky. They're right after all. Every single time, it was our fault. It was some code bug. So just for that sake. And likewise with ActiveMQ. Typically, the problems we've seen had more to do with the way we configured it. It wasn't ActiveMQ being buggy. So, sorry, that was long-winded. Sorry about that.
No worries. I had two questions, actually. How big is your data typically in terms of your surveys? Like, are they smaller scale? Like, is the...
In terms of number of responses or the size of the document, of the survey itself?
Both. In terms of like how many respondents you typically have per survey.
Yeah, so right now, we went public launched in October. Okay, so compared to the primary players in the market like SurveyGizmo, SurveyMonkey, we don't have that kind of level of usage now. Our largest survey response is probably around 100,000. That was interesting. There was this radio station up in Santa Cruz, and they said, hey, should we drop Rush Limbaugh or keep Rush Limbaugh? And then the guys over at Reddit put it on Reddit, and it blew away their system. So they went and quickly put it on our system. And it was like Friday afternoon. I'm like walking out the door, and suddenly I'm looking at all the numbers spiking. And we're like, what? And it turned out to be active. We did have problems, and it was ActiveMQ because we had misconfigured it. So, lesson learned. But Mongo was great. And in fact, right now, in our constraints is primarily MySQL on the engine. So our surveys themselves are not so huge yet. But one of the things we're doing, in 2 or 3 weeks, you're going to go to SurveyBuilder, and it's not going to be there. It's going to be another product called Instantly. So we're really focusing on our on-demand audience. So we're sort of rebranding ourselves a little bit to just emphasize that we're not really just a survey building authoring tool. We're about access to our panel. Hopefully, also we're going to be talking to large corporations and getting them access to our panel. So we expect usage to go up. But right now we're talking about our largest around 100,000 responses. Oh, and for surveys, sorry, we put a limit around 200 questions.
200 questions.
Because nobody should ever take a survey more than 200 questions. Seriously.
Just the other question I had was, I'm sorry.
Oh, sorry, go ahead.
Just for your crosstab, you guys are using MapReduce?
MapReduce, yeah.
So a live request actually does hit create a MapReduce job?
Mhm.
Okay.
So when you define a crosstab, we basically have to mark the document as dirty. We say that data is no longer valid. We got to rebuild it from scratch, and we do a full build. And the nice thing is the crosstabs happen within that one single pass through the document set. So, sorry, over there?
You had a question about incremental MapReduce.
Yes.
How many records are you MapReducing across? And the second question is, I was under the impression that MapReduce locks the entire collection, but you're running on the primary, so things will take writes.
It can lock, the thing about, yes, and that is definitely an issue. But like I said, the emits release the thread, okay? As well as every 100 records that get scanned by the map releases the thread, which gives writes a chance to write. It definitely has an impact. And so sharding is definitely important.
So how many records or documents are you MapReducing across?
Well, it depends. So in the case of the largest survey, a full build would MapReduce across 100,000 records.
And how long would that take?
That can take anywhere from about 20 seconds to a minute. But we have yet to shard. The truth of the matter is right now we're running on a single replica set. And so we have yet to really start breaking down those responses. Again, one of the things, once you start sharding, if you're looking at aggregation in any form in Mongo, be it MapReduce, be it native aggregation or counts, you really want an even distribution of data against the shards so that you can, because it's only going to be as fast as the slowest one. So you're trying to get an even distribution as even as possible. So.
What are you anticipating is kind of your sharding key? How are we going to separate your data?
So, good question. I haven't figured that out yet. Again, we're looking for an even distribution by responses. So my immediate thought is, okay, you could just actually just shard on the primary key of a given response. But there is this thing with chunking, okay? And so it'll basically try to chunk as much data before it starts sharding across. So that might not be the right answer. One of the things is we have a contract with 10gen. And so we're going to sit down with 10gen and review how we want to shard this stuff. So we're going to involve them on it. So we'll get their buy-off on a good approach. Anyone else?
Question, if there's, anybody else have a question?
Anything about geospatial?
Yeah, have you tried any other geospatial, or is it just, this is your first?
Yeah, you know what, I just decided to use Mongo because we had it. It was kind of an out-of-the-box thing, so yeah.
So you
I didn't evaluate other tools.
Okay.
But we're going to be incorporating basically, it's way cool. And we're going to be incorporating, like, in our reports, you'll be able to just map things, the data points throughout it. And it's just going to be a breeze with Mongo.
Okay.
All right, thank you.
Very much.